So Leetcode problem number 4, a hard problem, finding the median of two sorted arrays. I'm going to go over the top voted Python solution. It's unique in that it doesn't just use mathematics and it doesn't make you actually combine the arrays to find the median. So we're going to go over that. I found it kind of unique. It's also considered utilizing binary search. So let's dive over to it. And here you have n1 and n2 are just housing the lengths of the nums1 and nums2 arrays. This line of code is just ensuring that nums1 is going to be the shorter of the two arrays. And here is just holding the value of the combined arrays. And left here is the initial cursor point that is going to be traced along nums2. The significance of this is that it is actually taking what would be the middle index position of the combined array, because it's using that total length offsetting by 1 and doing floor division of 2. And then low is tracing the lower bounds of the nums1, and then high is tracing the higher bounds of nums1. And then while low does not go past the upper bounds, it's going to be performing these calculations. And then it's going to be setting these values based on those calculations, those middle points. And then we're doing a comparison to see if the comparison allows us. It basically is pinpointing and narrowing down the location in which you would combine both of those arrays and come up with the actual index position after you were to combine the arrays. And so mid1 here starts off as being just sliced down the middle of nums1, and so you're starting the cursor position right in the middle. In this case, it's at the 8900 position. And then mid2 is taking that left value and then subtracting the quantity that you get from mid1 as the half of the list. That's unique in that you have left being what would be the index position of the median for the combined list. You're actually offsetting it by how many values you're going to be including in the section or the slice if you were to slice it at this point. So that'll become more apparent and why it's significant as we step through it. But just note here that we're starting with 8900 and then 99 as two comparisons on nums1, and then we're starting off with 1,000,002 and then 1,000,001. Here you have just infinite values being utilized in case some of these outer bounds or upper bounds or lower bounds conditional statements turn up being false, so that when you actually run this line of code, what you intend to happen takes place, and it doesn't error out by trying to compare a greater than or less than with a none. And so basically it's assigning all of these values for comparison so long as you're not past any upper bounds. And so R1 and L1 are for nums1, R1 being the actual cursor position and L1 being one step to the left. And then R2 being the actual cursor position on nums2, and then L2 being one step to the left. It can get a bit confusing here, but we'll step through it now, and hopefully it'll be a bit clearer what is taking place. Apologies about all the clicking. Unfortunately, it's just the way it has to go to get to the point where it's actually doing what we want. I should just learn to click the keyboard, might be better. So the point I want to actually get to is this comparison point. So you can see that the mid1 and mid2 were 3 and 10 respectively, and that the values being assigned, just remember that the R values are the cursor positions and that the 1s and 2s next to them represent which array they're coming from. So you have nums1 has all of the 1 values, so L1, R1, and then nums2 has L2, R2, and mid2. And so as you can see, if you were to read this step by step, so L1 is 99, and you want to make sure that that is less than or equal to R2, which in this case is 1,000,002. So that passes. But then you have L2, which is 1,000,001, and that needs to be less than or equal to R1, which is 8,900. So that's false. L1 is not greater than R2, so now it's going to increase the lower bounds of nums1 in the binary search methodology. It's going to cut it in half, and then it's going to start trying to compare values from there. And the nifty thing here is as it steps over and updates low, because low is being used to calculate mid1, it's actually going to be altering mid2 while you're just altering one of those values. So now we're going to step through it, get to the comparison, and then hopefully by going through this you'll be able to kind of see how this person arrived at their response. So as you can see here, it stepped over again. So mid1 is now index 5 and mid2 is now index 8. With those two cursor positions, the comparison points now are 40,005 and 41,000 versus 999,000 and so on and so forth, as you can see here. And so it will come up false again, because what it needs to do is find the point in nums2 where it can fit this value, the end index value. So it goes to the end of the list and then keeps stepping nums2 down to find out where it can put those values in, and then from there it will be able to calculate the median. So here it has the same thing take place. It's increasing the lower bounds. Now it's going to update all those values. And it's basically going to be, it's stepped so much that it's going to include all of nums1. And then it's stepped down far enough to go between the 8,009 and the 999,999. And now it found the place where that can fit, right? And it was, since it started off on nums2 at the full index position of where that median would be, it incremented all of that downward to find the position where both of those could be combined. And now you know the actual midpoint, so to speak, of the combination of nums1 combined all the way up to this value. Then calculating for the new position becomes possible. So as you can see here, it's taking the max between L1 or L2. Because it knows whichever position, that's the one that was going to be higher up in the list, in the correct position. So that was Leetcode problem number 4, getting it down to O log of m plus n time complexity. And I feel like I'm a long ways away from being able to master something like this, but we'll see. Hopefully that was informative. See you next time.